This is a Philco 38.4 console radio built in 1938, and it's a special radio to me because it was given to me by my uncle. It was the first shortwave radio I ever owned. I had a lot of fun with it. I was still in junior high school at the time. I had to repair it to get it to work. My uncle bought it for $1 at an estate sale and brought it to me as a complete surprise. It got lost, and the long story there was fortunately saved by my brother and his wife, and who returned it to me after a long period of neglect, and they had actually begun restoring it when they learned that this was the same radio that my uncle had given me when I was about 11 or 12 years old. At any rate, this radio has a design defect, and that is the converter. When you get into the upper frequency ranges, the oscillator in the converter tube, it's a Pentagrid converter, will sometimes quit. Of course, that makes the set completely dead. So one of the things that I have wanted to do for a very long time, or at least it's been in the back of my mind, is see if I could find a way to predict through testing which converter tubes would work over the full frequency range of this radio, which goes well up into the, I think it goes up into the 20s of megahertz. Well, let's look. See if we can figure out how far up it goes. Yeah, it looks like it goes up to 19 and a little more megahertz. You can see that right here. Pardon the shadow. I am actually filming this in my library, where this radio has had a special place for the last 10 years or so, ever since my brother and his wife rescued it. At any rate, purpose of this video, though, is to talk about the converter tube. I've talked about converter tubes previously, and I'll mention that a little bit later in the video. But in this specific case, what I'm going to be doing is looking at the 6A8 tube. It comes in a variety of flavors and styles, but it is the Pentagrid converter used in this radio. And I'm going to be trying to determine what is the best way to test a 6A8 so you know it will work over the full frequency range of a radio like this. So stay tuned if that sounds interesting. Here is the schematic of the Philco 38.4. It's also was put in a different cabinet and called the 38.5. It's the same chassis, just different wood around it. But the part that I'm most interested in is right up here, where you will find the detector oscillator. And notice it says it's a 6A8G. I realize it's not real easy to read, but that is what it is. So that's the tube we're going to be looking at. The plan is to look at it on the 570 Tektronix curve tracer, and also to look at it on a couple of high-quality tube testers from the day, and see if any of that allows you to predict whether this 6A8 is likely to oscillate up to a high enough frequency to receive the 20 megahertz or so, which is the top frequency of this particular receiver. And that was generally near the top, at least, of most of the radios of the day, the 1930s. Of course, after the war, there wasn't as much demand for shortwave radios, and so they pretty much went by the wayside, except for amateur radio operators and shortwave listeners who bought specialized radios for shortwave. but the general radio in the parlor, if you will, shortwave disappeared from that radio after World War II. So these are unique in a way, and this particular radio is especially unique and dear to me. Here is the video I mentioned a second ago that I did, I guess, back on June 16th of 2020. It's number 312, TomTech Test 312, called Pentagrid Converter Tubes and Circuits. And if you are not familiar with Pentagrid converters and you want to know a little more about it in order to follow this video, you might want to go watch this one. But basically all you need to understand, you don't need a lot of theory for what I'm going to be talking about. Mainly we're going to be talking about how we test a Pentagrid converter and determine whether the oscillator, which is a part of, this is a two-part tube as is explained in this video, but we'll be talking about how to test this Pentagrid converter. And by the way, if you want to go online, look for the RC14 RCA tube manual published in 1940. I think you can find it at worldradiohistory.com, but anyway, if you just put in RCA tube manual 1940, I'm sure you'll be able to find it. It has the best description of Pentagrid converters that is generally available without having to buy an expensive vintage textbook or anything like that. So, without further ado, let's get on with some testing. So, what we have put here on the 570 are a pair of 6A8 GTs. This is the one on the right as you look at the panel, and I'll show you the panel here in a second. And this is the one on the left. Now I'll also explain how this is set up, and if you have watched my previous video on the setup of the 570, I'm following some of the guidelines that I put forth there. As I pointed out in that video, there is no tube chart for a 570. You kind of have to make it up out of using tube manuals. But at any rate, you notice that the gain of this one is substantially lower than the gain of that one. So let's move down here, and you'll see the two tubes that I'm using. This is the 6A8 GT that has the higher gain. This is the one that has the lower gain. Now, let me pause the video for just a second. And the reason I wanted to pause the video is some of you may wonder, I have the signal grids floating. Now, you'll see in a minute how some of the other connections are made. But let's come back up to the display, and I'm going to now ground the top cap. Notice that there is a relatively small difference when you ground that connection, and we'll talk more about that in a little bit. So this is that one. This is that one. Now I'm going to move the top cap over to this one, and notice the gain goes down in both cases. Okay, so that is the 6A8 GT. So now let's talk a little bit about what we've done here, and then we'll come back and try a couple of 6A8Gs and see if we get any different results. So here is how we have the 570 set up. I have 80 volts on the actual plate, and I also put 80 volts on the grids 3 and 5. I told you that I was floating the top cap, and as we saw, that had little effect. These other grids have so much more effect on the gain of this stage. If you watched my video on converter tubes, on Pentagrid converters, you'll know that the tube designers deliberately designed this part of the tube to have as little effect on this part and vice versa. And so almost all of the gain of the oscillator section, which is what this is, I'll show you a typical Pentagrid converter circuit here in a second, how this is normally hooked up. But normally the grid number 1, which is on pin 5, is the oscillator grid. And grid number 2, which is on pin 6, shown here as a plate, is used as a plate. And that's why on the 570 we have it connected to the plate connection. So basically the tube we are sweeping is this tube. This one has some impact, and that's the reason why we put these voltages there, because there needs to be a positive voltage to attract electrons to move up the tube. So here is a typical Pentagrid converter circuit using a 6A8, and I've written in the pin numbers here. This is out of the RC14 tube manual, published in 1940. So as you see, the oscillator, which is basically these two coils, form a transformer to connect grid 1 with grid 2. And then grid 2 is supplied with a positive voltage here through this resistor. That causes the bottom section of this tube to oscillate at the frequency determined by the L and C of this tank circuit. So that is the part we are interested in determining how suited a particular 6A8 is to high frequency performance, because the higher the gain of this oscillator stage, that's the bottom part of this tube, the more likely it is to oscillate over the entire frequency range of a shortwave receiver. So let's now go back and take a look at a pair of 6A8Gs on the 570. Okay, now I have a pair of 6A8Gs in the 570. This is the one on the left, one on the right. You notice that it appears that the one on the left is a little better, but neither of them are as good as that 6A8 GT. And by the way, the one that was the best is this Westinghouse 6A8 GT. That's the best one so far. By the way, the tube on the left, let me pan down, you can see it, is actually the original 6A8G out of that Philco 38.4 that I showed at the early in this video. The tube on the right is an RCA, and I'm going to flip to the one on the right, and then I'm going to move the top cap. You see, it makes no difference on that one, but you see this, what's going on over here, it does make a difference on the Philco. That's the top cap now. Well, I just realized I didn't show you what I was actually doing. So let me do that again. This is the 6A8 on the left, the original Philco. I take the top cap off, in other words, floating the control grid. Now we'll look at this one, and we'll put the top cap on. You notice no difference. So basically, the Westinghouse 6A8 GT is the best of the bunch based on what I see on the 570. And so now let's do some tube testing. And over here you see a couple of tube testers that I have talked about in some previous videos. The one on the far left is a B&K 650, which I did a complete restoration on many years ago. And the one on the right is a Hickok 600A. These were probably the two best testers available to service people. Now, there were lab tube testers that were better than these, but the ones that were carried by people who worked on particularly TVs and before that radios, these were the two tube testers. I'm not going to talk more about those. What I am going to do is now use each of those to test these same tubes, and then I'll report my results at the end of the video. Okay, so what I have done is I have tested those 6A8, the 2Gs and the 2GTs on the 800A, the Hickok, and also on the 650 made by B&K with the 610 test panel. By the way, the 6A8 tested on the 650, you have to have the 610 test panel because the rest of the sockets, none of them are set up for it. The 6A8 was actually considered an obsolete tube by the late 50s or early 60s when these tube testers were most popular. So they generally left those kinds of tubes out, and they sometimes produced a supplement that would allow you to test them. And in the case of the B&K, you had to add the 610 test panel to test many of those tubes. But you got a bonus, you got to test a lot more newer tubes like compactrons and things like that. But I won't go into any more of that. If you're interested in the 650, I did a very extensive restoration of a 650. In fact, I did two of them, but I don't think I ever mentioned that. One of them I added a 610 test panel to, and I also show some work on the Hickok in those same videos because I had to replace a resistor and recalibrate and do a few other things on my 600A after I got it. So what were the results that I got? Well, here is a summary of what I found. Now the coding over here, the R means RCA, the W is the Westinghouse, which was the best of the bunch. And then the R here is an RCA 6A8G, and the P is a Philco 6A8G, at least it's branded Philco. So on the 570, I rated them as the Westinghouse was 1, then the RCA G as 2, the Philco G as 3, and the RCA GT as 4. On the Hickok 800A, these are the readings I got, and you see once again the RCA was the worst of the lot, and the Westinghouse GT was the best. The 650 with the 610 test panel had pretty much the same results, in fact almost identical numbers. It's a little funny because on this one, most of these, the B&K read slightly lower than the Hickok, but on the Philco G, it actually read a little bit higher. That's probably just differences in bias. So I would rate those tubes. X means I wouldn't use that one. The Westinghouse I rated as excellent, and by the way, these is the performance in that Philco 38.4. And to get a quantitative figure for that, what I did is I measured the grid voltage on the oscillator with a high impedance meter. And what I found is the highest grid voltage, which means the most active oscillator, was on the Westinghouse GT. The RCA and Philco both produced good, and by the way, worked over the full range. But that RCA GT would quit in the 38.4 near the high end of the bands. So let's take a look at an actual test on at least one of the tube testers, and then try to close this out. So here is one of the GT 6A8 GTs. This is the weaker of the two, and what I'm going to do is I've got it set up, but I'm going to swing the camera up here so you can see the meter a little better. Actually, let me reset the camera. Okay, so now we have the tube set up, and I'm going to press the GM, or mutual conductance test. Now I've already tested this tube for shorts. I've actually already tested this tube, but anyway, thought you might like to see what it reads. Now this, remember, is the weak one, and on the test data for the 6A8, and by the way, this was considered an obsolete tube at the time that, here's the 6A8, at the time the 600A was released, and so it's listed in the obsolete tubes section, and that's why you won't find it on the roll chart. But over here on the right, you see it has basically two positions. One, it says a GM of 1,000 for the pentode section, but a GM of 300 for the oscillator section. And that's what we're testing, is the oscillator section. So once again, this is 500 micromos, the right there. So this is reading right at 300, barely passes. So let's try the other one. Okay, so we now have the Westinghouse 6A8 GT in here. Let's come back over to the meter. And once again, I've already tested this for shorts, but let's test it now for mutual conductance. And you see it reads, at least 1,500. So we can correlate the good results on the 570 with the tube tester results. Now, I won't go through the results on all the others because the real proof in the pudding is in the pudding. And so the question is whether this 6A8 GT will work at the highest frequencies of the radio that you want to put it in. And I can tell you that I know this one does work, but in all honesty, so do the 6A8Gs. The 6A8 GT that I just showed, the old used RCA, it barely works. And in fact, it dies near the end of the broadcast band. At the high end of the broadcast band, the oscillator dies using it. So it's a pretty weak tube. But this one, as you can see from the meter, whoops, turned the tester off. Okay, we'll press GM and watch it as the tube comes to life. There we go. And you see it just keeps rising and rising and rising. So a tube like this would work really well in a shortwave radio of the time. I hope this has been an interesting video for you. I hope also that you may have learned something from it. But more important than any of that, I hope it inspires you to go out and try some things, learn more electronics, do some experiments, maybe restore an old radio. Mainly, expand your horizons. That's what life's all about. So speaking of life, stay safe and have a nice day.